Now let us move on to solving another good numerical from engineering mechanics, solution to problem number 2.98 from problem set 2.6. It is about finding the conditions of equilibrium using the principles of moment of a force, that is turning effect of a force about a given point. It is also from the same book, Engineering Mechanics by Professor Timoshenko D.H. Young, Stanford. From Stanford, Director J.P. Rao, Professor Sukumar Pati from India. Now, the statement of the problem goes like this. Have a look at the diagram. Find the tension S induced in the string CDE. CDE. The string is passing over a pulley, frictionless pulley, attached at point C. The string is attached at point C to this right-angled bar, and E, also at E. The string having passed over the pulley is attached to the bar at E. The bar is right-angled, A, B, C is right-angled at B. This point is not A, this is the point A. And what else? The weight is P. The weight of this bar is from here, vertically downward. Assume a perfect flexible string, frictionless pulley, and an ideal hinge at A. We have to find the tension in the string. So first let me explain. This point A is not here. This point A is here. From A to D, the length is 2A. From B to C, the length is A. So what do you do? If you extend this line, this dotted line to this side, let me do it for you. And if you extend the lines, draw a horizontal line from C, okay, a line from C, then from this point to this point will be equal to A. So, now the distance of E from the point A is given as A. The distance of point F from which the load is acting vertically downward is given as 1.5A. And the length from A to B is given as 3 times A. Now let us proceed. It is given CDE. CDE is the flexible string. So the tension developed, if you consider the tension in the string as S, for the point C it will be pointing to this side, and for the point T it will be pointing to this side. If you consider point D, then the same S is pointing to this side. If you consider D, the same S is pointing to this side. All right. So S is the tensor in the string. Let angle DEA. DEA. A is not here, the point is here. Let this angle is equal to alpha. Why do I have to consider certain angles? Because then I can, if I can find out this angle alpha, then I can split this tension forces to a horizontal component to this side and a vertical component to this side. So now in triangle DEA, tan of alpha will be perpendicular over base. That is 2A over A. So tan alpha will be AD over AE, that is 2A over A cancels. So your alpha is a tan inverse of 2, that comes out to be this many radian. Here I mistakenly wrote a degree because my scientific calculator was in radian mode, so I didn't want to cancel this. So this many radians, if you convert to degrees, this comes out to be 63.434948 degree. No need to convert. You can put your scientific calculator in the degree mode and straight away calculate alpha as tan inverse 2, then you will get this much, 63.434948. And if you convert to degrees, minutes and seconds of arc, this comes out to be 63 degree 26 minute 5.82 seconds of arc. So this is the horizontal line drawn. This horizontal line meets AD, this line. Let this point is equal to G. Right. So then what we can say about the length AG? Length AG will be equal to length BC, and since BC is equal to A, from A to G will also be equal to A. And from D to G will be 2A minus A, that is A, from the point D is not here, is here. So from D to G is also A. Now let this angle is equal to beta. So if you take tangent of beta will be dg over gc, and from G to C is same thing as from here to here, that is given as 3a. So tangent beta will be a over 3a, that is 1 over 3. So your beta comes out to be tan inverse 1 by 3. Put it in a scientific calculator. That comes out to be 18 degree 26 minute 5.82 seconds of arc. The angles that I just explained here as alpha and beta, I have shown it here in a different diagram. So tan of alpha is 2a over a, tan of beta is a over 3a. So alpha beta are calculated. Now let me redraw the diagram. It's already redrawn for you. So what we shall do, we shall consider the moment of different forces about the point A. Due to the weight of this bar from this point acting vertically downward, the weight P will try to rotate this bar about point A in a clockwise direction. So since it is equilibrium, this has to be balanced by equal amount of anticlockwise moment about the point A. So about the point A. So we shall consider moment of different forces about point A. Now for point C, the tension is away from C. For point E, the tension S is away from E, pointing in this direction. This S is pointing in this direction. I just explained the different angles, alpha and beta. So if you split S into horizontal and vertical components, this one will be S cos beta, this one will be S sin beta. Similarly here, if you split S into horizontal and vertical components, this length will be S times sin alpha, this one will be S times cos alpha. Now there will be some reaction force at the point A also, where the right angled bar ABC is connected here. Now the question is which forces will produce turning effects. Now if you look at this S cos alpha, is the line of action of S cos alpha is passing through the point A. So this does not have a perpendicular distance from point A. So S cos alpha does not produce any turning effect. Similarly, the reaction force, the line of action of RA is passing through the same point. Means this RA does not have a perpendicular distance from A. So this will also not produce a turning effect. So P will produce a turning effect. The load P about A, the line of action of P from point A has a perpendicular distance 1.5 A. So this will have a turning effect. That will be clockwise. And your S sin alpha from the point A has a perpendicular distance from A to E, that is given as A. So this will also produce a turning effect. S cos beta, the line of action of S cos beta in this direction. From the point A, it has a perpendicular distance A, so this will also produce a turning effect. Similarly, S sin beta, the line of action of S sin beta, which is this, from the point A, it has a perpendicular distance equal to 3A. So this will also produce a turning effect. So once you find out which forces will produce turning effects, then which you have to find out which one will produce clockwise turning effect, which ones will produce anti-clockwise turning effects. Then you have to make them equal. So that is what I have explained here. The line of action of RA and S cos alpha do not have a perpendicular distance from point A, therefore so these two, this as well as this, they don't have a turning effect about point A. So apply sum of the moments about A is equal to 0. P times 1.5A, P times 1.5A will provide a clockwise turning effect about point A. Then S sin alpha times A. Look, S sin alpha times this perpendicular distance will produce a anti-clockwise moment. Then S cos beta times A, because this A is the perpendicular distance of the line of action of S cos beta from point A, that will also produce a anti-clockwise turning effect, S cos beta times A. Then we are finally left with S sin beta. S sin beta from point A has a perpendicular distance 3A. That will also produce a anti-clockwise turning effect. So S sin beta times 3A. Now on the right hand side there are three terms. Three terms are added. If you take A common here, it will be cancelled with this A. So let me do it here. So we are left with P times 1.5 is S sin alpha plus S cos beta plus 3S times sin beta. Now if you take S common, we are left with sin alpha plus cos beta plus 3 sin beta. We need to find S, so let us bring these terms to the left hand side and straightway put in a scientific calculator. So your S comes out to be P times 1.5 over sin alpha cos beta 3 times sin beta. Alpha was calculated, beta was calculated. Put it in a scientific calculator. This comes out to be 0.5373 times P, the weight of the bar, the tension developed in the string. The tension developed in the string, and that is holding the bar, the string, this string which is holding this right angled bar at 2 points C and E. The tension S is found out. So that is all about. Thank you. So if you feel you are comfortable with my explanation, you may subscribe the channel and pass on to your friends, and feel free to write your feedback and comments if possible. Thank you. All the best.